So our first example for binary integer programming, or at least using binary variables, is capital budgeting. So in this case, we have several potential projects that we want to invest in over the next few years. Each project requires capital, money, at potentially different times throughout our time horizon that we're considering. Each project also has a net present value associated with it. So as you can imagine, our objective is going to be maximize net present value. So here are the possible projects. We have 5 of them. I made them really descriptive, projects A, B, C, D, and E. And then it's over a 4-year time horizon where each year I indicate in millions of US dollars how much capital or money must be expended for that particular project. So for example, project A, I have to put in $3 million in the first year and nothing the remaining years 2, 3, and 4. And it has a net present value of $2 million. On the other hand, project B doesn't take any money in the first year, but it does take $5 million in the second year, $1 million in the third year, nothing in the fourth year, for a net present value of $3 million. So we need to now look at maximizing net present value, but there are some constraints that we need to also consider. So let's look at the constraints. So one of the constraints is going to be how much money we have available in each of the 4 years for our time horizon. So in year 1 we have $12 million available to spend, year 2 $8 million, year 3 $8 million, and year 4 $4 million. In addition to this, there are some policy restrictions. So let's look at the policy restrictions. First, we have projects D and E are mutually exclusive. That means if I do one, I cannot do the other. So if I decide to do project D, I cannot do project E. Also, if I decide to do project E, I cannot do project D. So only one of those two can be done. We're not saying one has to be done, but just that only one of them could be. Probably the easiest policy restriction that we have is no more than 4 total projects can be undertaken. So we have a total of 5. We only want to do 4. Projects A and C must be undertaken together if at all. So that's saying that if we start A, we must also start C. If we start C, we must also start A. That's different than the last policy restriction that we have, which is project D is dependent on project B. So project D cannot be undertaken unless project B is undertaken. So what that means is D can only start if project B starts. If project B starts, it does not mean that project D must start, just that it can, it's available to. So these are restrictions, so these 4 will be constraints to our model. So we'll look at how to use our variables to create the constraints for these guys. So first, let's look at our decision variables. This is rather straightforward for a capital budgeting. We have one decision variable for each project, and we give each one a binary variable. So we say let A equal 1 if project A is funded, 0 otherwise. So if we decide to do project A, it gets a 1. If we decide not to do project A, it gets a 0. We do the same thing for the other 4 projects, B, C, D, and E. So rather straightforward for defining the decision variables. Now, the objective function is the next thing. So I already told you we're going to maximize total net present value. And we know that the net present value for project A is 2 million, for B it's 3, for C it's 1. I explicitly put the 1 in there just so you know where it came from. 5 for D, 4 for E. So where did these numbers come from? Well, if I go back up to here, I took this last column that says net present value. All right? So if project A is undertaken, then I get 2 times its variable, which is a 1. So I get $2 million. If I do not undertake project A, then I get 2 times 0, which is 0. Right? So that's rather straightforward as well. The next set of constraints are also pretty easy. which are the yearly budget constraints. So I have a year 1 budget, year 2 budget, year 3 budget, year 4 budget. I had 12 million, 8 million, 8 million, 4 million. All right? So 3A plus 1C plus 10D plus 2E is less than or equal to 12. So where did those numbers come from? Again, if I go back here, I'm taking this first column for year 1 capital, multiplying it times its variable, right? There was no B, so it would be 0B, so that one was left out. And we said this was 12 million, 8 million, 8 million, 4 million. So that's where those constraints are coming from, which are relatively straightforward as well. So now let's get to the more interesting constraints, the policy ones. So policy number 1 said projects D and E are mutually exclusive. If one is undertaken, the other cannot be. So the way we write this is D plus E is less than or equal to 1. So why do we say less than or equal to 1? So if they are both not started, 0 plus 0, that's less than or equal to 1. Right? If D is started, a 1, E cannot be, because E must then be 0, so that it's 1 plus 0 is less than or equal to 0. If E is started, so E is a 1, D must be 0 in order to satisfy this constraint. Then the easiest policy, I think, is number 2, which is no more than 4 total projects can be undertaken. Because these are binary variables, we just add up all the variables. They're either 1 or 0, and they have to be less than or equal to 4. The third policy says projects A and C must be undertaken together, if at all. So the easiest way to write this is A is equal to C. So if A is 1, C must be 1. If A is 0, C must be 0. If C is 1, A must be 1. If C is 0, A must be 0. And then I go ahead and make that into standard form, where I move all of the variables to the left-hand side of the inequality symbol. In this case, it's an equality symbol, strict equality, leaving 0 on the right-hand side. So we have A minus C is less than or equal to 0. Finally, we have policy number 4. Project D is dependent on Project B. Project D cannot be undertaken unless Project B is undertaken. So D is less than or equal to B. So what this does is says if B is 1, I fund Project B, then D can be started. It could be a 1, or it could be a 0. It doesn't say I have to do it. That's different than what we had before for the other policy. If B is 0, in other words, I've decided not to fund Project B, then D must be 0. Right? It cannot be a 1. So again, making it standard form, we have minus B plus D less than or equal to 0. So now we've got our formulation. The next thing we need to do is put it into Excel and solve it.